Everyone, and welcome to the Activity 37 notes. Today you will just need the Activities 37 note sheet, a pencil, and possibly a calculator. So when we are starting off looking at this particular problem, we are going to start with looking at our two rectangular prisms, C and D. If we look at these rectangular prisms, they're first asking us to find the perimeter of the base, the area of the base, and the volume for our smaller prism, C. So if we look at our base shape, again, it's a rectangle, and the perimeter is going to be found by adding up 12 plus 6 plus 12 plus 6 for a total of 36. The area of the base, since it's a rectangle, is base times height, so a total of 72. And then our volume is found by taking the area of the base times the height of the prism. Height of the prism is 4. Area of the base we just said was 72. 72 times 4 is 288 cubic centimeters. Now we want to do the same thing for rectangle D as well. So rectangle D has a base whose side lengths are 18 and 9. Overall height of the prism was 6. So same idea. When we're looking for the perimeter of the base, we're going to add up 18 plus 9 plus 18 plus 9, all four sides, for a total of 54. Area of that rectangle is found by multiplying the two, 18 times 9, for a total of 162. And then volume, area of the base, times the height. Area of the base is 162. Height of that prism, we said, was 6, for a total of 972 cubic centimeters. Now, when they ask us for the ratios of the perimeters, areas, and volumes, we're going to take basically our A value over our B value, A to B, a ratio. So in this case, perimeter of rectangular prism C, and then rectangular prism D, 36 over our second one, 54. Make sure we reduce this. 36 over 54, your calculator can help you out. So end up math frac, they're both divisible by 18, and we end up with a reduced value of 2 over 3. Ratio of the areas, we had 72 for prism C, and then 162 for prism D. Reduce that one, 72 divided by 162 reduces to be 4 over 9. The ratio then of our volumes, we had 288 and we had 972, 288 over 972 ends up reducing to be 8 over 27. Now, do we notice any relationship between these ratios compared to each other? Well, hopefully you are noticing that our ratio of the perimeter is going to be the ratio of the areas. We take the ratio of the perimeter and square them, right? 2 squared is 4, 3 squared is 9. And then the ratio of the volumes, again, goes back to this, that if we took those original two values and cubed them, we have 2 cubed is 8, 3 cubed is 9. So that is going to lead us to this piece on the back here. Okay, anytime we are looking for the ratio of the perimeters, or sometimes they call that the ratio of the side lengths, ratio of the radii if we're talking about circles, scale factor, sometimes you'll see a scale factor, it's called K, or ratio of the circumferences, because remember, perimeter and circumference, they're the same thing for polygons versus circles. That is going to be our A over our B. From there, the ratio of the areas, whatever A over B is, you square them each, and then that's going to be your ratio of the areas, okay? Make sure you always use the most reduced value of A over B to get the ratio of your areas. Now, to get the ratio of your volumes, you're going to take your ratio of your your ratios of perimeter, side lengths, radii, etc., that A over B value, and you will cube them. Okay. So for this first one, they're telling us that we have a triangular prism with a perimeter of 30, and then we have a corresponding face on a different figure that is 75. If we reduce this, 30 divided by 75 is going to be 2 over 5. Now that, again, is our A and our B value. So to get the ratio of our areas, we're going to take 2 and 5, and we're going to square them so that they become 4 and 25. And then again, we're going to take that 2 and 5 value. This time we are going to cube them to get the ratio of our areas. So 8 and 125. So those would be our 3 values based on that given info. Now the next example talks about some circles. One has a radius of 20, the other has a radius of 45. So K, again, is the scale factor. And that, again, is the same thing as saying our A over our B value. And both of these are divisible by 5. 20 divided by 5 is 4. 45 divided by 5 is 9. So again, our A and our B values are 4 and 9. So to get our ratio of the areas, we're going to square those values. So we have 16 over 81. And again, we're going to go back to A and our B values, cube them to get our volumes. 4 cubed is 64. 9 cubed is 729. Now, the ratio of the proportional figures is of the areas, it says, is 64 over 9. We want the ratio of the perimeters and the ratio of the volume. So what they're giving you this time is the ratio of your area. So in order to get our A over our B values, which are kind of the starting guys, we need to take the square root of 64 and the square root of 9 to undo those squares to get just A and B. So square root of 64 is 8, square root of 9 is 3. And now we can use A and B in order to help us with the volumes, because if we cube them, that will be our final answers for those. So 512 and 27 is that ratio. Last but not least, this one gives us the ratio of the volumes. Okay, so 216, 2,197. That's the ratio of the volume. So again, this is your A cubed and your B cubed. So to undo that, we need to take the ratio of the volumes and undo that cube by cube rooting. So a reminder, when you do this in your calculator, 3, math button, option 5 for those of you with a graphing calculator. The cube root is 6, so A is 6, and then we're going to do the same thing to get the cube root of our B value, so that's 13. So 6 over 13 is the ratio of our perimeters, and then we can square them to get the ratio of our areas. So essentially what this is showing us is the different relationships between the perimeters, the areas, and then those volumes. Okay? Thanks everyone for watching, and happy news that you have finished your last video of the year.